Good morning, everyone. We'll get started in a couple more minutes. Too tired. It's 11 o'clock. And we've made it to Friday. It is 11 though, so we will get started. Um, Obviously, I'm going to be starting with this one right here, number 2. I did mention for people who were not here early, uh, they may have had a head start graphing it, and we're only going to do 2 problems today, because they do take quite a bit of time. We're gonna be doing number 2, and we're gonna be doing number 4 here, and I'm gonna just tell us right now that number 2, right here, we are just going to prove that this is a rhombus. That's going to be the entire problem. And then we will take a look at number 4, which is going to be proving a square. That way we have done every single shape as far as kind of this coordinate geometry proofs go. The rhombus and the square do take a little bit more time for one reason, and we will get into that. So if you haven't done so already, I would graph these. So I've put the points on my graph paper just to help me out so I don't have to flip back and forth. And then I'm going to graph this. And ideally, if they're telling you to prove something as a rhombus, make sure it looks like an actual rhombus. If you get something that doesn't look like a rhombus, you've done something incorrect. I'm assuming you guys can hear the baby in the background. Let's see, Q. R is 1, -5. There's S. Plane. I don't know what you mean. You'll notice with the rhombus, one thing that I'm going to do is I'm going to draw in the diagonals. because the diagonals are going to be utilized with this proof. Unlike when we did the rectangle yesterday, we didn't really talk about the diagonals because we didn't need to. We proved that the sides had right angles, which was good enough to show that it was a rectangle. We did not, since we did not use distance, we didn't use the diagonals were congruent because we didn't need it. With the rhombus, we are going to need it because unless you use distance, you're going to have to do distance 4 times if you're going to prove a rhombus. But if you use slope, you're actually going to need to use it 6 times. So it's kind of depending on what you're going to do. If you really know what you're doing and you want to do the least amount of work possible, you just need to know which shape requires the least amount of calculations. But I always just recommend just do slope because then you know what the math is going to look like. If you use distance with a rectangle, you have to use it 6 times. If you use it with a rhombus, you only need to do it 4. But I'm always just going to use slope. So we are going to have to do slope 6 different times. 1 for every side, and then 2 for the diagonals. So remember how these proofs work. We have to first show it is a parallelogram. And in order to prove it's a parallelogram, since we're going to be using slope, we're going to prove that these opposite sides are parallel to each other. So QR and TS would be parallel, and then I can highlight that these two are parallel to each other. So I'm going to go through my slope formula 4 times just to show that they are in fact parallel. I'm going to try to squeeze it over here. So the slope of QR is equal to, so I'm doing QR, the first 2 coordinates, so it's -5 minus -7 over 1 minus -2. Again, because you've graphed it, assuming you did graph it, you can just do your rise over run. And we get +2 over 3. We're hoping to get the same thing with TS. So -9 minus -7 over 1 minus 4. So that's a -9 right there. So this becomes plus. So we get -2 over -3. You do have a negative over a negative, so this is, in fact, +2 over 3, which makes these parallel to each other. Again, you can double check that in the actual graph. It does appear, but both of them are doing that. Up 2 over 1, 2, 3. So that one looks good. This one is up 1, 2 over 1, 2, 3. So your rise over run, everything looks like it's checking out just fine. Now let's do the other 2 sides. The other 2 sides are going to be the blue ones in this case, which is QT and RS. So I'm going to do the slope to QT is equal to -9 minus -7 over 1 minus -2. Switch this to addition. We get -2 over, switch this to a plus, we get +3. So we get -2 over 3, very similar to the previous one. We can just double check that down to over 3, which is in fact correct. And don't fool yourself, because these 2 slopes right here, it's very easy to say that, oh look, they're negated. That must mean they're perpendicular, but they're not. I mean, we can see from the graph that these are not right angles on the edges of our rhombus. There's no relationship. They have to be a negative reciprocal in order for them to be a relationship. So it's just -2 over 3, and make sure we get the same thing with RS. So the slope of RS is equal to -7 minus -5 over 4 minus 1. So it's just addition, and we get exactly the same thing, -2 over +3. -2 over +3. So I can bracket these off, and then I can put a parallel right there. So just be a little aware of what we've done so far, what this math shows us. The mathematics we just did really have nothing to do with a rhombus. That is the math that we've been doing for every single proof, because this is showing that opposite sides are parallel. This is the math that justifies it is a parallelogram. Because remember, which I've been saying all week, is that in order to prove these shapes, I'm going to put up my flowchart, you have to show the parallelogram first. And the property we're always using, especially with coordinate geometry, are the top one. If we show that, we know it's going to be a parallelogram. You could also do congruent if you choose to do distance. But now that that math shows that, now I have opened the way. Now I can show one of these. You have a number of things you can do. The hardest one to prove in coordinate geometry is the diagonals bisect their opposite angles. So we're never going to use that in the coordinate plane. So you have to use one of the other ones. If you're going to show all four sides are congruent, you're going to have to do the distance formula. And you'd have to do the distance 4 times, which I think is a lot. That's an additional 4 calculations with a different formula. If we're using slope, though, we can easily show if the diagonals are perpendicular or not. That's why I drew them in on this one. How are we going to know if the diagonals are perpendicular? We're going to see if their slopes are, in fact, negative reciprocals of each other. So that's the method I'm going to choose for this one. So I go back to my graph right here. I'm going to do slope 2 more times. The slope to QS, and then you can look immediately. I mean, it's a flat line right here. We should know that the slope of a flat line like that is 0. So make sure that when you calculate the slope to QS, you do in fact get 0. We do, because it's -7 minus -7 over 4 minus -2, which is 0 over 6, which is 0. I'm going to do it one more time. But now we're going to do RT. So if you remember back when we talked about slope, the slope of a vertical line, it's not going to be 0. It's the reciprocal of 0, which if you remember way back that the reciprocal of 0 is undefined, meaning we should find a 0 in the bottom when we do our undefineds. Much harder to do your rise over run with this. This is just something you need to know. Vertical lines, their slopes are considered undefined. When you do the mathematics, it should show that. If you try to plug in the calculator, you're going to get that calculator error. Sometimes I think some calculators will say divide by 0 error. This is all other ways of saying undefined. So the slope of RT is -9 minus -5 over 1 minus 1. And you get -4 over 0, which we get that 0 in the denominator, so we get undefined. I know I'm trying to squeeze it in right here, but I am going to try to bracket these off, and I'm going to put a perpendicular symbol in there, because these are negative reciprocals. That tells me that the diagonals are in fact perpendicular. So that is the math that would justify the fact that this is a rhombus. But we do need to get into the statements. Remember, this is a formal proof, so we need to complete it like it is a formal proof, where we now are going to write in the statements. But remember what the first statement needs to say. The first statement has to basically be what we were looking at in this flowchart. The flowchart says make sure that you say that this thing is a parallelogram first. Then you can say it is a rhombus second. And that is what we are going to do when we make our statement. So the sentence number 1 is going to be, I'm just going to call it a quadrilateral because that's all I know it to be right now. Quadrilateral, QRST, is a parallelogram since opposite sides are parallel. So this statement is justifying this math right here. That's why you need that work right there. Or you show your rise over run. You need it somewhere written down on your graph paper or your blank sheet, whatever you're doing your work on. Then the next sentence to justify why it is a rhombus. Now we can call the second sentence can start off with a parallelogram because we've just identified it as such. So parallelogram, QRST, is a rhombus since the diagonals are perpendicular. And that will complete this proof. So obviously I can't see you guys and I can't really gauge a reaction out of you, but I'm curious on how you feel about these types of proofs, especially if you're comparing them to the other proofs that we have done, the statement reason ones. I do find that most students like these better. They make a little bit more sense. They're a little bit easier because they use something you've already done before, like slope. But you have pretty much a 50-50 shot whether the Regents will ask a proof that is kind of along this line or along the statement reason line. I do remember last year in June they did ask both. There was a coordinate geometry proof and a statement reason proof. So you could see both. The writing they're longer. I mean, this was one question that took us 15 minutes. They're definitely longer types of questions. You like these. That's good. And we're also learning it in a little bit of a unconventional way through Twitch, but hopefully everyone's on the same page. We are missing I'd say about half the people. We only have 16 people watching right now. So we're missing quite a few people. Please just direct them towards the YouTube channel so they can watch old videos if you know anyone who is not here. Again, I don't know who is here and who's not here. I know some people who are here, but alright, once we got that down, we're going to jump to number 4. Only difference with number 4 is going to be the fact that we're going to prove that this is a square. Because that's the last shape we have not done. Now, proving a square is not hard. It does require the most writing, though. Because the square is the most specific of the 4 shapes. And if you think about how are you going to go about proving something is a square, go to that flow chart. If you have it handy, I'll pull it up. It's right here. If you're going to prove something is a square, look everything that is right above it. You got to show it's a parallelogram because that's what comes first. Then you need to show it is a rhombus and a rectangle. You need to show that it's all 3. Then you can say that if you have a shape that is a parallelogram, a rhombus, and a rectangle, then it is a square. So that is going to be basically 4 separate sentences to conclude that this thing is going to be a square. But we need to simultaneously show a property from each of them. Now, no matter which method you're using, whether you're using distance or slope, you're going to have to do it 6 times no matter what. I always say don't mix and match distance with slope. You could, it is possible. I suggest don't. If you're going to use slope, just do slope 6 times. If you're going to use distance, you're going to be using distance 6 times if we are trying to prove a square. I think slope is the easiest, so that is what I'm going to go with. So let's go back to number 4. If you have graphed it already, great. I still need to do so. So I'm just going to do that really quick. So negative 4, 3, 1, 2, 3, 4, 1, 2, W. X. 2. That doesn't look right. That's because X is graphed wrong. That looks a bit better. You don't need to take attendance for me. It's fine. As long as people know that the videos are up. I think it's just better to do them live, so that way you can ask me questions. WX, this one's Y. And then Z, negative 3, negative 8, 1, 2, 3, 3, 4, 5, 6, 7, 8, Z. Again, since the question I had asked is we're going to be proving it's a square, make sure it looks like a square. Just like I did with the rhombus, I am going to draw on the diagonals, but since I know a square is a rhombus. Now the good thing about the square is it is, like I said, it is only going to require the slope formula 6 times, and you'll notice in the previous problem that we just did, we did exactly that. The same math is actually going to show one step further. It will show that it is a rectangle. Because remember when we did a rectangle, I'm going to circle this right here, these two slopes right in here, those values, should have been negative reciprocals if it were a rectangle. We found that, well, they were negatives, but they weren't reciprocals. That right there actually showed that it can't be a rectangle. When we do our math, we have to basically see that if they're negative reciprocals, it would be a rectangle. So the math will just naturally show itself in the fact that it will be a rectangle. Because remember when we did a rectangle, you only need to do slope 4 times. But you had 2 parallel sides, and then you had a perpendicular side. Now everything, we're going to have lots of negative reciprocals, we're going to have lots of parallel lines, and everything should work out very nicely. I'm going to do the math for the parallel piece first. So I will do the slope to WX and ZY. Slope of WX negative 3 minus negative 2 over negative 4 minus 1. This is equal to, we're going to switch this to addition, should be negative 1 over negative 5. Or they're both negative, positive 1 over positive 5. If you're doing your rise over run, up 1, 1, 2, 3, 4, 5. Looks good. Always double check. That's why I like to do this both ways, calculating it and checking. ZY should be the same thing. Negative 7 minus negative 8 over 2 minus negative 3. These things are going to switch to addition, both of them for me at least. So I get positive 1 over 5, which is great. That's exactly what we wanted. And now that you have this slope, you should be able to predict what the next two have to be. If we're thinking about the fact that, well, this is a square, these sides must be perpendicular to each other, my yellow and blue sides. If they're perpendicular, and I already know the slope to the yellow ones, well, the negative reciprocal to 1/5 is negative 5 over 1. If you don't get negative 5 over 1, there's something that is going wrong. You've either calculated the other slopes wrong, or you've miscalculated the previous one. We should get negative 5 over 1 because we are proving it's a square, which means it's a rectangle. So I have to get those right angles in there. So the slope to WZ. That's why I like these, because you should know that they are negative reciprocals right off the bat. You can have an expectation at what the answer should be. So WZ is going to be negative 8 minus negative 3 over negative 3 minus negative 4. Bunch of double negatives again. Switch them to addition. I get negative 5 in the top over positive 1 in the bottom. Exactly what we should have expected. And then the last thing is the slope of xy, which is equal to negative 7 minus negative 2 over 2 minus 1. Switch that to addition. I'm going to get negative 5 again in the top and positive 1 again in the bottom, which is great. That makes these parallel. I'm also going to bracket off where I have found perpendicular sides. You have a bunch, but you only need to do one. So that's why I set it up this way, because they'll always be right in the middle, just like that. Just think about what the math has proven so far. What has our math so far shown? It's not quite a square yet. We have opposite sides are parallel, so that's enough evidence for the parallelogram. Then you have perpendicular sides, which is enough for the rectangle. Notice we do not have any evidence of the rhombus. And you can't show a square without you showing that it's a rhombus. So how are we going to get to the rhombus part? Well, now the diagonals are going to come into play. We are hoping that the diagonals are perpendicular to each other. When you look at the diagram, they certainly look as if they are perpendicular, but we know we can't go based on what it looks like. We're going to have to show the slopes of these things. Now, there should be no correlation to this value compared to the value that you just shown. These ones are going to be a little bit harder to predict what they are. They're going to be pretty much independent of each other. So Zx, so I'm doing the slope to this one right here first. The slope to Zx is, I got negative 8 minus negative 2 over negative 3 minus 1. Switch it to addition, I get negative 6 over negative 4. The double negative definitely makes sense because this is a positive slope, and it does look like it's positive 3 over 2. Let's double check that. 1, 2, up 3 over 2. Looks good. Up 3 over 2. So yes, it is in fact up 3 over 2. Which now tells me that the slope of the new one, or the last diagonal, I'll highlight it. So this one, that I'm highlighting right now, has to be negative 2/3 if it is in fact negative reciprocals. And we're going to check that right now. So the slope to WY equals negative 7 minus negative 3 over 2 minus negative 4 becomes addition. Both of them, you get negative 4 over positive 6, which is exactly what we wanted, negative 2 over 3. Bracket this off, and then put a perpendicular symbol to represent that these are perpendicular diagonals. Now the writing part. For the writing, you can think to yourself, what am I going to have to write? If you think about the flow chart, I'll pull that up one more time. You have to go in this order. And you will have to say, basically, a sentence for each of the shapes. The first sentence that has to be written down in order has to be the parallelogram. The second and third sentence, you have the option. This is why the rhombus and rectangle are on the same level, and they kind of both branch off to the parallelogram. You can tell me why a parallelogram is a rhombus or why a parallelogram is a rectangle. So you can go into either shape. The order, in that case, won't matter. But then the last thing it's going to say, well, it's a square, because a square is defined as a shape that is simultaneously a parallelogram, a rhombus, and a rectangle. So that is 4 sentences, one for each of the shapes. And where order does matter. Parallelogram must come first, square has to be last, and then you can have rhombus and rectangle somewhere in the middle. So going back, make sure you leave yourself enough room to write 4 sentences. I'm going to start off with quadrilateral. Oh, that's not ABCD, is it? No. It is WXYZ. Is a parallelogram, since make sure that whatever you write down is the justification to the math you did. Since we have continued to use slope, it should be opposite sides are parallel. If you happen to write opposite sides are congruent, you did not show congruency. That's kind of one of the areas where you could lose a point. If we did distance, then yes, it would change to congruent. But we did not use distance. Even though that statement is true, the opposite sides are congruent. Our math didn't show that. Our math showed parallel. That's sentence number 1. We need 3 more. Now the rhombus and rectangle can come in either order because it does not matter. I typically like to start with the rectangle because we use slope and the math naturally showed that it was a rectangle first. But that really doesn't matter. We can now call it a parallelogram. Parallelogram, W, X, Y, and Z is a rectangle, since what did we show? That's kind of what you're asking yourself. You know, where does my math justify it's a rectangle? And it was right here. It was because the sides to the parallelogram are perpendicular to each other. You can really word it in almost any way you want. You could say that since they're perpendicular, it contains right angles. You could say adjacent sides are perpendicular. There's a bunch of different ways you can word it, as long as you get that main idea through. I'll say since adjacent sides are perpendicular. You could say form 90-degree angles. You could say they're all 90-degree angles because your math shows that it is 90-degree angles. So that's good. What you don't want to say is diagonals are congruent. We don't want to, even though that's true in a rectangle, it is not what we show. We did not show that. We showed the right angle property of the rectangle. Which conversely is also going to be true with the rhombus. Remember, in a rhombus, all sides are congruent. We didn't show that, though. We showed the other property of the rhombus. Diagonals are perpendicular. So now I can say that rectangle W, X, Y, Z is a rhombus, since diagonals are perpendicular. And then we have one more sentence to complete the proof, which we can then say it's a square. Because notice what we've done so far. We said it was a parallelogram, a rectangle, and a rhombus. When a shape is all 3 of these, it is a square. So I will just say WXYZ is a square since it is a parallelogram, rectangle, and rhombus. And that would conclude this proof. A lot of writing when it comes to the square. I don't think it's very difficult though. As long as you know kind of the properties of the shapes, you would be good. Should be good to go. The calculations behind it are not. I think the calculations are relatively easy, especially because they are predictable. You know, if they're telling you it's a square, you know that you're gonna have parallel sides, you're gonna have perpendicular sides. So there's a lot of predictability when it comes to these kinds of proofs. Unlike the statement and reason proofs, it's a little harder to predict what's going to happen. With these, you know exactly what's going to happen. I know somewhere in the packet I put some more challenging ones that the regents have asked. We will get to them soon. On Monday, I definitely want to practice some classifying these shapes based on certain conditions. So I do have something planned for us on Monday when we come back from the weekend, which is going to practice that. I don't think you're not going to have anything in your packet from it, but show up Monday. I think it'll be fun too. So we'll get to that on Monday. But we only have 5 minutes left. Obviously, these take a very long time, so we can just end it right there. If you guys have any questions, let me know. If you don't, you guys enjoy your weekend. We made it through our first week of quarantine, which is nice. Hopefully, you guys are able to learn things from your other classes. Hopefully, you're learning something from this one. How often are these on the reagents? 50%, I'd say. You have a 50-50 shot. Like I said, I think I mentioned earlier, last year there was both in June. There was a coordinate geometry proof. It was up on a trapezoid, though. I plan on actually practicing that one in class at some point. And there was a regular statement reason proof. There will be one. Sometimes they're really easy, sometimes they're not. This is honestly as complicated as they get. The square is the most complicated one, but you've just seen it. I mean, it doesn't change. Any other questions? Everyone's other classes going well? You're welcome, Lyle. As far as additional practice, you guys can practice numbers, the ones that we didn't do, 3 and 5. I'm not sure if I put a homework here or not. There is a homework page, but I would say practice 3 and 5 first. I forget what they end up being. I think they're just parallelograms.